The goal of this demo is to recreate the system shown here from Dr. Karmakar's paper using the automatic generation from the Simulink script using only console commands. So initially we run the program and it generates a Simulink window. Then using console commands, this is going to have 6 blocks with 1 delay. So it's a step input, step time of 0 and an amplitude of 1. See the block has appeared over here. So the second block will be a summing junction with a 1 positive and 1 negative feedback. You can see that here. Third block in the system is going to end up being saturation with a lower limit of -4 and an upper limit of 4. See the block. Next, the fourth block is going to be a delay block with a delay length of 1. Fifth block, transfer function with values that were determined from previously in one of Brandon's videos. Gotta enter the numerator first and the denominator second. And the final block is going to be a scope. So now we've created the lineup. It's similar to this setup, except the transfer function block in Dr. Karmakar's has been expanded into the delay and transfer function separated. So now we're going to start connecting the blocks together. So block 1, which is the input, is connected to 1 block, and it is a summing junction. So it connects to positive feedback or input. So we enter a 1. The output of block 2, which is the summing junction, is connected to 1 block, and it is not a summing junction. Saturation is connected to not a summing junction. Delay is connected to not a summing junction. So now we're lined up here. So now the transfer function needs to connect to 2 blocks. It is connected to a summing junction. It connects to negative feedback, which we can see it's done now. And then the final is going to be a scope. And as you see, it's been fully generated. This is the second demo for recreating Dr. Karmakar's control system delays in MATLAB using nothing but console commands from a script. So this is the system we'll be trying to recreate. As with before, some blocks are going to be separated, like the gain of 2 on the first feedback loop is going to be separated into a gain and a delay block. So we'll begin by, again, running the MATLAB script. It generates a Simulink environment, and then going to be entering the parameters. So the number of blocks in the system is going to end up being 8. It's going to have 2 delays. Input type, it's a step time 0, amplitude of 1. First block is going to be a summing junction, or sorry, excuse me, second block is going to be a summing junction. So that's going to be a 1 with positive input and then negative feedback. After that, we're going to have an integrator. Then we'll do the delay next for the first feedback path. So this is going to have delay of 1, and that same set is going to have a gain of 2. Then the 6th block, we're going to do the transfer function, which these values, as with before, are taken from a experimentally found from something Brandon did in a previous part of this video. So we enter the numerator and the denominator. Denominator is just the s squared, so it's 100. Then 7th block, we're going to do the last delay. I'll show this quickly so you can see that some of the blocks are being generated as we go. Next, we have another delay length 2 this time, and the final block is going to be a scope. So you can see here we have all of the blocks lined up. So how many blocks is the output of block 1 connected to? It's connected to 1, it is connected to a summing junction, and it's positive feedback, or positive input, so that's been set up there. So now, how many blocks is the output of block 2 connected to? It's connected to, as you can see here, just 1. Connected to the summing junction? No. Connects it to the integrator. So the output of block 3, which is the integrator, is connected to 2 blocks. It's connected to the delay, and it's connected to the transfer function. So here, we're going to tell it 2 blocks. It's connected to summing junction? No. It's connected to delay and transfer function. So you can see there, it's connected to both. Now, I won't show that again until this is done, or I might show one more, we'll see. So the output of block 4, it's connected just to the gain, so not connected to summing junction. Block 5 is gain stage, so that is connected to 1 block. It is connected to summing junction. It's negative feedback, so I can show that get added here. How many blocks is the output of block 6 connected to? That's the transfer function, and that's connected to the scope, which isn't shown on here, and the feedback, or the delay, excuse me, on the feedback. So it's connected to 2, it's not connected to a summing junction. So first it connects to the delay, and then it connects to the scope. Now finally, how many blocks the output of block 7 connected to, which is the delay? That is going to be 1 block. It is connected to a summing junction, and it is negative feedback. So we can show that final connection fall in place. That's it for this one.